IGCSE 0625/42, May-June 2024, Paper 4, Theory Extended, Paper Walkthrough. Question 7. Figure 7.1 shows 3 bars of steel, A, B, and C. Student is given 3 pieces of steel. 2 pieces are magnetized and 1 piece is unmagnetized. Describe and explain how the student determines piece is unmagnetized using only the 3 pieces of steel. So what the student can do is the student can bring 2 of these steel pieces nearby, and if this is not and if this is not, these are 2 like poles. Say this is A and if this is B, these 2 would repel. So the student would conclude that C is unmagnetized. So basically this is the explanation for this. The student brings one end of the piece of steel close to the one end of the another piece. They look for attraction or repulsion and repeat this test between the ends of the bar. If repulsion is observed, then both bars involved in the text are magnets, because only magnets repel each other. If a bar only attracts and never repels with any of the others, then it is unmagnetized. So that is how the student can conclude whether it is steel or an unmagnetized steel. Figure 7.2 shows a circuit diagram of a step-down transformer. This is the primary coil and this is a secondary coil. And the primary coil, as you can see, has more turns than the secondary coil. Therefore, this is a step-down transformer. The main voltage supplied to the transformer is 240 volts. The output power of the transformer is 45 watts. The transformer is 100% efficient. Calculate the input current of the transformer. So we know the input voltage, which is 240, and the output power, which is 45 watts. In this case, we know that the power input is equal to the power output, and the equation of power is equal to voltage into current, and we have to find the current. So we can use this concept. So the power input is 240 multiplied by the current is equal to the power output, which is 45 watts. In this case, we can take 45 because efficiency is 100%, and the input current would be 0.19 amps. Draw a label diagram of the step-down transformer. On the label, state a suitable material for each of the component. So you're supposed to label this as well. It's a copper wire, and this is a primary coil and this is a secondary coil. So here we have the step-down transformer, we have labels, and we have the suitable material for each component. So yeah, that's pretty much it. Question 8. Figure 8.1 shows a circuit. The circuit is designed to switch on a night light when the surroundings are dark. So we have 3 components here. Here we have a LDR, we have a resistor, and we have a light emitting diode. So part 1. On figure 8.1, draw a circuit symbol for a voltmeter used to measure the potential difference across the LDR. So this is the LDR. So voltmeter is added parallel to the component. So we have the LDR here, and we are going to add the voltmeter here. The surrounding change from light to dark. State the effect of this change on the resistance of the LDR. So when it gets darker, the resistance increases. When it gets brighter outside, the resistance would decrease. So in this case, the surrounding changes from light to dark, so the resistance would increase. State and explain the effect this has on the potential difference across the light emitting diode. In this case, the resistance of this combination would increase. Therefore, the voltage shared across the LDR and LDT would be higher. Figure 8.2 shows another circuit, lamp A and B, identical filament lamps. The current supplied by the power supply is 0.5 amps. Calculate the resistance of lamp A. So we want to find the resistance of lamp A. And these two lamps are in parallel. So we know that the lamps are identical in this case. So the 0.5 amps would be equally distributed to these two lamps. So let's calculate for lamp A, as that's what the question is asking. The current would be 0.25 amps. So the resistance would be, we can use this equation, V is equal to IR, R is equal to V by I. The voltage is 240 divided by 0.25, and that would give us the resistance of 960 ohms. And that's it for question 8. Question 9. Radioactive isotopes emit ionizing radiation are used in the hospitals. State and explain 2 safety precautions necessary for the use of these isotopes in medical procedure. One could be reducing the exposure time, and that would lower the amount of radiation being absorbed. Next one is using shielding, and radiation would be absorbed by the shielding and it cannot penetrate through the shielding. So therefore, the exposure to humans would be decreased as the radiations would be absorbed by the shielding. Give 2 reasons why alpha emitters are not used as radioactive transfers inside the body. So alpha particles are highly ionizing, which is not safe. It could cause damage to DNA, and alpha has the shortest range, so it would not reach the detectors. So these are the 2 reasons. Sodium-24 is an isotope that has a proton number 11 and nucleon number 24. Sodium-24 decays by the emission of a beta particle, forming an isotope of magnesium. Use nuclide notation to write down the nuclide equation for this decay. So it's sodium. We know the proton number is 11 and we know the nucleon number is 24. And it decays by the emission of a beta particle. So this is a beta, and this results in the formation of magnesium. So this is what you have to do for this question. So for this, on the left hand side, you'll be getting 1 mark, and for magnesium on the right hand side, you will be getting another mark, and for the beta particle on the right side of this equation, you'll be getting 1 mark. That is your 3 marks. Question 10. The solar system includes the sun and the planets. State 2 other types of natural objects that orbit the sun. So here they're asking for natural objects. So it's minor planets and asteroids. State the shape of the orbits of the planets. Elliptical. So you have to remember this shape, you have to remember this term. It's not a perfect circle. Figure 10.1 shows the orbit of an object around the sun. At point A, the object is closest to the sun. At point B, the object is further away from the sun. State and explain the energy transfer as the objects travel from point A to point B. So kinetic energy decreases and potential energy increases as the object moves from A to B. So here it's closer to the sun, and here it's further away from the sun. So therefore, when it's away from the sun, the potential energy increases and the kinetic energy would decrease. When the object is closer to the sun, the kinetic energy would be greater and the potential energy would be less. The explanation for this is the energy is conserved. So here it has maximum potential energy, and when it comes closer to the sun, the potential energy would decrease and it would be converted to kinetic energy. So that's the explanation. Part D. Jupiter is 7.8 into 10 to the power 11 meters from the sun. The speed of light in vacuum is 3 into 10 to the power 8. Calculate the time taken for light from the sun to reach Jupiter. So we can use speed is equal to distance over time, where we are supposed to calculate the time taken, and the distance is given, and the speed is given as well, and that gives us 2600 seconds. We can write it as 6 into 10 to the power 3 seconds. Question 11. Name the galaxy that contains the sun. It's Milky Way. Light observed from distant galaxies is redshifted. State the theory of the universe that this observation supports. The Big Bang theory. Cosmic microwave background radiation is observed at all points in space. State when this radiation was produced. So this radiation was produced shortly after the universe was formed. Explain why this radiation is now in the microwave region of the electromagnetic spectrum. The universe has expanded. As a result, the radiation has been shifted to the microwave region of the electromagnetic spectrum. So that's it for this paper. If you have any doubts, drop them in the comments, and thank you for watching.